All right, today in geometry, we are looking at volume of cylinders and cones. So recall that a cylinder is like a prism, but it's with circular bases. The volume of a cylinder is the area of the base times its height. Since its base is a circle, the volume is pi r squared times the height. Again, this is my radius, and this is my height. And then it says, recall that a cone is like a pyramid, except the base is in a circle instead of a polygon. The volume of a cone is 1/3 the area of the base times the height. So since the circle is the base, it's 1/3 pi r squared times h. Again, where our height of a cone is straight down the center, and then that's our radius. Notice that the volume of a cone is 1/3 that of the volume of the cylinder, so it will take 3 cones to fill up 1 cylinder of the same size. And so then we have what's called Cavalari's principle. It states that if 2 solids have the same height and the same cross-sectional area at every level, then they have the same volume. We can use this principle to find the volume of oblique solids. So it's just telling me that oblique solids will have the same volume formula as right solids. So let's look at some examples, finding the volume. The very first one, I see that it is a cone. So my formula for volume is 1/3 pi times my radius, 4 squared times the height. They tell me the height of the cone is 8. So in this one, we have everything that we need. And again, since I have pi, I can put my answer in 2 separate ways. So first, if I do 4 squared, I get 16 times 8, and then divide by 3, I would get 42.67 pi. I found volume, so cubic meters, or I could multiply that through by pi and get 134.0 cubic meters. The next one is a cylinder. So again, I have the radius, I have the height, I have everything I need. So the volume is equal to pi times my radius squared, so 2 squared, times my height, 8. And so 2 squared is 4, 8 times 4, so my volume is 32 pi cubic centimeters. Or I can multiply 32 times pi and get 100.5 cubic centimeters. So those are 2 examples where we have everything that we need, and it's simply a matter of plugging them into the formula. Let's look on the back. Now we have some oblique solids. So the first one, I see it's a cone. I see that the radius of my circle is 9. The height, since it's oblique, has been marked on the outside, dropped straight down. So again, I have everything I need. So the volume is 1/3 my radius squared, so 9 squared, times pi times my height, which is 16. So I can multiply through everything except pi and get 432 pi cubic centimeters, or multiply that times pi and get 1,357.2 cubic centimeters. The next one, again, it's a cylinder. It's just oblique, but I have my radius and I have my height. So the volume is pi times my radius, 5 squared, times the height, 15. So my volume is 375 pi cubic centimeters, or multiply that through 1,178.1 cubic centimeters. So the next example, it says the volume of a right cone is 1,350 pi cubic meters, and the radius is 18 meters. Find the height of the cone. So again, I'm going to take the formula for the volume of a cone, 1/3 pi r squared h, and I'm going to plug in everything that I know. So for the volume, they tell me it's 1,350 pi equals 1/3 pi, the radius 18 squared h, and I'm going to solve this for h. So on this side, I still have 1,350 pi. Over here, I'm going to multiply 18 squared and then multiply that by 1/3, and I get 108 pi times h. I'm going to divide by 108 pi. Notice I did not multiply by pi because on the volume they gave me included pi, so they will just cancel out over here. So the pi's cancel, so 1,350 divided by 108. My height is 12.5 meters. It's the next word problem. The main tank at the Living Seas Aquarium at Epcot Center in Florida is the largest enclosed tank in the world. It is a cylinder, so they're telling me that we have a cylinder shape. I'm going to draw a picture of that. with a diameter of 203 feet, so all the way across is 203 feet, and a height of 25 feet. How many gallons of water does the tank hold if 1 gallon is equal to 231 cubic inches? The very first thing I want to do is find my radius. So my radius is 203 cut in half, which is 101.5 feet. I can go ahead and change everything into inches now, or I can go ahead and find cubic feet and change my cubic feet to cubic inches. So I'm going to show you how to change cubic feet to cubic inches. So the volume is pi to my radius, 101.5 squared times my height, 25. I multiply all of that out, and I find that my volume is 809,136.8 cubic feet. And since I need to change that to cubic inches, I went ahead and multiplied through by pi. So there are 1,728 cubic inches in 1 cubic foot. And I get that because I know that there are 12 inches in a foot. So 12 cubed gets me 1,728 inches cubed. Cubed. So if I do 809,136.8 times 1,728, I now end up with, let's see, it's a really big number, cubic inches. Now it tells me that it wants to know how many gallons of water does the tank hold. 1 gallon is equal to 231 cubic inches. This is how many cubic inches I have. So I'm going to divide that by 231, and I get approximately 6,052,763.6 gallons. So approximately 6 million gallons of water that this tank holds. That's a lot of water. Remember the other day when we found out the weight of that? Can you imagine the weight of this one? All right, so let's go to our last page. Mr. Young has a container that he wishes to fill with a special fertilizer for his roses. The container is in the shape of a right cone. Okay, so here's our cone. The diameter of the container is 13 inches, and the height is 5.2 inches. The fertilizer costs $2.55 per cubic feet. How much will it cost Mr. Young to fill the container? So the first thing here I'm going to do is change all my inches into feet. So 13 inches divided by 12 inches, 13/12 of a foot. 5.2 inches divided by 12 inches is about 0.4333 feet. My radius then is 13/12 cut in half, which is approximately 0.5417. So now the volume is 1/3 pi, my radius 0.5417 squared, times my height 0.4333. So my volume is about 0.1331 cubic feet. It costs $2.55 per cubic foot, so I'm going to multiply that by 255. And it will cost Mr. Young about 34 cents to fill his container of special fertilizer for his roses. All right, so the next one, we see we have composite shapes. We have a cylinder and a cone. It wants me to find the volume of them. So first I'm going to find the volume of the cone. So the volume of the cone is equal to 1/3 pi, the radius 10 squared times the height 12. So this is about 400 pi cubic meters. I'm going to find the volume of the cylinder. That's pi times 10 squared times 18, which is about 1,800 pi cubic meters. Then I'm going to add those two together and see that the total volume is about 2,200 pi cubic meters. Or if I wanted to multiply that through, that is 6,911.5 cubic meters. All right, our last one. It says the diagram shows a section of a concrete drainage pipe, which is in the shape of a hollowed out right cylinder. To the nearest cubic centimeter, how much concrete was used to make this section of the pipe? Cubic centimeter tells me volume. So I'm going to find the volume of the outside of the entire cylinder. So that is pi times my radius. Okay, so the whole outside is 48. So half of that is 24. So 24 squared times its height is 52. That is 29,952 pi cubic centimeters. The volume of the inside, which has been hollowed out, is pi times, so this time the radius, the diameter is 44, so cut that in half. My radius is 22, my height is still 52. That gives me 25,168 pi cubic centimeters. This time I want to subtract them to get the volume of the shell. And you get 4,784 pi cubic centimeters, or 15,029.4 cubic centimeters of concrete is used to make that section of the drainage pipe. Right, so that wraps up how to find the volume of cones and cylinders. And again, remember that a cone is just a third of the volume of a cylinder. And so if you have two that are the same height and same radius, then it will take 3 of those cones to fill up one of your cylinders.